Hello viewers, in this video we will discuss about heat engine. So from the name itself we can see that heat is given as input to the engine and work is done by the engine. Okay, so let us see what is a heat engine. Okay, so heat engine, it is a device in which a system undergoes a cyclic process. In turn, heat is converted to work. Okay, so this is a device in which a system undergoes a cyclic process. Okay, there is air or gas. We can see that in a cyclic process in which heat is converted into work. So let us see the layout of this heat engine. This is the hot reservoir. And this is the cold reservoir. Okay, so the temperature of the heat of hot reservoir is Q1, this is T1, this is Q2 and this is T2, and this is the work done W. Okay, so now we can see that. So see that from external source, external heat is being given to the system. Okay, so that heat is taken as Q1 at temperature T1. So heat is given to a system. So with the heat as the input, the system does some work to the environment. So this is the work done by the system to the environment. Okay, so after work done, the excess heat is being sent to the external reservoir or atmosphere. Okay, the excess heat being sent to the external reservoir or to the atmosphere. At temperature T2, the amount of heat sent to the external reservoir is Q2. Okay, so heat is given as input, some work is done and excess heat is sent to the atmosphere. This is the layout formed in case of your heat engine. Okay, so this excess heat, for example, if you are preparing rice in a cooker, okay, so after the steam goes or after the pressure is released, so now when you open the lid of the cooker, we see that some amount of steam comes out. Okay, so that is the excess heat. For your visualization, I am telling this as an example. Already some heat will be released during the pressure release stage, but at end you can see that when you open the lid, some excess amount of heat goes. So totally you see that total Q1 will not be get converted into work done. The total heat will not be totally converted into work done. Some amount of heat will be transferred as excess to the atmosphere. Okay, so now what is the efficiency of this heat engine? So this heat engine efficiency, so this is given by, so the efficiency is given by, you know that efficiency means what? Output by input. What is the output here? Work done. What is the input here? Heat supplied. Heat supplied is the work done, input, work done is the output. So here W by heat supplied is Q1. Okay, so this work done could also be written as, this work done could also be written as Q1 minus of Q2. Okay, so now I'm going to write here. So this could be written as Q1 minus Q2 divided by Q1, in which this could be written as 1 minus of Q2 by Q1. In terms of temperature, this could be also written as 1 minus T2 by T1, that is efficiency. So the efficiency is for the amount of heat supplied, what is the work done? Okay, this is about your efficiency. Now you can see that the total heat supply will not be converted into work done. 100% efficiency is not possible in case of your heat engine, because some amount of heat will be transferred as excess to the atmosphere. So some amount of heat only will be used to do the work done. Okay, so let us see the example of this heat engine. Okay, so we have seen automobile engines, petrol engine, diesel engine. You could have seen the movement of pistons in many oil advertisements. Okay, castor oil, like that we have many advertisements. So here we see an example for your petrol engine. So in petrol engine, see that we have a cylinder arrangement in which inside the cylinder you will be having a piston, sealed piston. This piston will be connected to a crankshaft, a rotating device. So this linear motion of the piston will be transferred, this linear motion will be converted into that rotary motion of the crankshaft, which in turn connected to the rotary of the wheels. Okay. So here we'll be having an inlet valve, here we'll be having an exhaust valve. Okay, so when the inlet valve opens, we see that the air fuel mixture, in case of petrol engine, air fuel mixture comes inside, this piston goes down and sucks the air fuel mixture, and when it comes up again, it compresses the air fuel mixture. So here we'll be having a spark plug. So spark plug ignites. Okay, what happens is air fuel mixture will blast, will burns and blast, in which that explosion will make the piston again to go down and come again upwards. So when it comes upwards, we see that the burnt gas has to be sent out. So that will be sent out when the exhaust valve opens. So they will have specific timing for the opening of the inlet exhaust valves. So the exhaust valve opens, that exhaust gases will be sent to the atmosphere through the silencer or through the exhaust pipe. Okay, so see that here heat is supplied to the air fuel mixture. So work is done, the expansion of the piston. So the movement of the piston so that the engine runs. Then the excess heat is transferred to the surroundings as exhaust gases. Okay, so we see that no, the heat input will not be get converted 100% into work done. So some amount of heat is converted as excess to the atmosphere. Okay, so here we can see that when you draw a PV diagram, so when you draw a PV diagram for a petrol engine, we will be having a cyclic process. So here it is mentioned, here it is a cyclic process. Heat is supplied. First we see that the compression, so compression, heat supplied, expansion, rejection. So we will be having a cyclic process. We will be having a cyclic process in case of your heat engine. Okay, so that's it about this heat engine. So make a note that this is the efficiency of the heat engine, heat supplied with respect to the work done. Okay, so next we have displayed a live example for a better understanding for the students. Just for the understanding purpose, we have displayed some examples. Okay, so see that it will be very easy and helpful for you. Okay, thank you. Here we have a small demonstration of the heat engine concept. Okay, see in the bottom you can see heat is being burned, so that is the hot reservoir. See here the cooking of food chicken fried rice is being burned. So here the work is done. You can see the exhaust gas, the air is going away, so that is the cold reservoir. Okay, so hot reservoir, work done, and cold reservoir. You can see the temperature of hot reservoir is more when compared to the temperature in the cold reservoir. So this is a small demonstration to explain about heat engine. The best example is your IC engine, the working of your bike, car. You can see that the fuel is being burned, so that is a hot reservoir. In your exhaust, you can see that the exhaust gas goes, that is your cold reservoir. So you see that the bike runs, that is the work done. Okay, so IC engines, steam engines, that is the best examples. Diesel engines, steam engines, these are the examples, best examples for explaining the heat engine. Okay, thank you.